In this section, we will discuss arcs and chords. There will be several theorems that we will use. Theorem 10.3 says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Theorem 10.4 says that if a diameter of a circle is perpendicular to a chord, then it's going to bisect that chord and its arc. The perpendicular bisector of a chord contains a diameter of the circle. And then last, Theorem 10.6, in the same circle or in congruent circles, chords are congruent if and only if they're equidistant from the center, showing you that Lx is equal to the Ly. All right, first example using the first theorem. It's wanting you to find JK, but it's telling you that the LM arc is 75, which then means that your JK is also 75. Please pause the video and try the check question. In the check question, you should have gotten that the measure of CD is also 60. Example 2, you will find that in this circle, you will have congruent arcs, which then means those chords are also congruent. So to find FG, I would set those two equal to each other. So here it shows 2x plus 6 equals 5x minus 9. I would substitute in those expressions like it says, and then I would start solving. So I would subtract 2x from both sides. I would then add 9 and divide by 3. So you should be getting x equals 5. I remind you they are not wanting the value of x, they want the length of FG. So after rereading the question, I find that I need to plug that back in. So that's why they're showing 5 times 5 minus 9, which is the answer of 16. Pause the video and try the check question. In the check question, you should have set these two expressions equal to each other. 5x minus 9 equals 2x plus 3. You should have found that 3x is equal to 12, and so solving x would be 4. So when I plug it back into the RS, 5 times 4 is 20. 20 minus 9 would be 11. All right, in example 3, it says that you have a circle with EFG equal to 20. And we have to find the measure of arc FG and also the chord EG. Well, remember that if this is a perpendicular bisector, it will bisect this arc. So two things happen. I will know that this chord is being bisected, so H to G is also 3.5. I will also know that I can bisect this arc. So if this whole measure is 120, half of 20 would be 60. So from F to G would be 60. Then it's asking for the length of EG. Well, like we already discussed, these two EH and HG will be equal just because of their arcs being bisected as well. So that means that I would add 3.5 plus 3.5, which would give you 7. Pause the video and try the check question. In the check question, you should have found that PT was 6, so when you add it all the way across, PR is 12. They tell you that from PQR is 90, so to find from P to Q, I just split that in half, which is why it's 45. Example 4, you use the diameter perpendicular to a chord. So it says the record shown can be modeled by a circle. Diameter CD is 12 inches long and chord FH is 10 inches long. So the first thing that you will want to do is you will want to connect from F to E as shown here in this picture, okay? Then what we're going to do is we're going to find the radius. We know that the diameter is 12, so from E to D would be 6. Since this is going to be perpendicular, that's going to end up being helpful with a right angle right here. We also know that E to F is also a radius, so from E to F will also be 6. Then it tells me F to H is 10, so with this being perpendicular to my chord, it's going to bisect this. So I know that F to G will also be 10, because it will split it in half. So I will have E to F, which is 6. I will have F to G, which is 10. Since it's a right triangle with no angles, I'm going to use the Pythagorean theorem. So I'm going to use the Pythagorean theorem and plug in my values. I'm going to do x squared plus 5 squared equals 6 squared. And then I'm going to solve. So I will square those and get 25 and 36. Subtract 25, so I get 11, and then do the square root of 11. So your answer would be 3.32. Pause the video and try the check question. In the check question, you should have found that from R to S would be 7.5. Your chord gets bisected, so from S to T would be 6. You would want to set up the Pythagorean theorem looking like this. So x squared plus 6 squared equals 7.5 squared. You'll square those numbers and get 36 and 56.25. You'll subtract 36, get 20.25, and do the square root. Now, first time I did this question, it stumps me a little bit, but when rereading, it's wanting the length of the steering device, and that would be from P to T in the directions. So what that means is, in order to find the length from P to T, we know the radius, RP, is 7.5. So I'm just going to take 7.5 and subtract away our length we found for RT, and that'll give us the remaining amount. So that's why the answer ends up being 3. Okay, and then in the last example, example 5, it's telling you that they're giving you PQ and they're also giving you RS, and they're asking you to find X. Well, remember the last theorem was that if this distance from the center is equal, then we know these chords are equal. So you're just going to set them equal to each other and solve. So 3x minus 4 equals 14. You would add 4 over and get 18, and then divide by 3 and get 6. Pause the video and try the check question. In the check question, they're telling you the chords are equal, so now these distances to those chords would also be equal. So if you set them equal to each other, you would solve and get 3x equal to 9, and then you would divide and get 3, and then to finish, they want the length of PG, so then I would plug it back in. So 3 times 3 would be 9, plus 6 would be 15. That concludes arcs and chords.